Hi, my name is Anshita and I'm from TeamEdgecombe, and today I'll be presenting the tool JavaMOP Efficient Parametric Runtime Monitoring Framework. The tool was developed by Dr. Jin and colleagues, and the tool was presented in the ICSE 2012 conference. So the motivation behind the tool, it is mainly for monitoring of parametric properties. Now, what are parametric properties? These are the properties that describe behaviors of objects which a program should conform with during its execution. They can describe user protocols for classes, preconditions for using classes, prohibited activities, and so forth. So parametric properties are monitored by means of parametric monitoring, and it aids in detection of errors, recovery from errors gracefully, and it increases system reliability or security. So overview of the tool. As I said, it is a parametric runtime monitoring system. It is specific to Java programming language. Java MOP is an instance of generic MOP framework, that is monitored oriented programming. The platforms the tool works on is Windows and Linux. Prerequisites of the software are AspectJ compiler, Java runtime environment, and RV monitor. RV Monitor is a runtime verification monitor tool, which is mainly used for generating monitoring code, which will monitor the target program. Whereas the AspectJ compiler generates .aj file, which will call the monitoring code generated. The interfaces that the tool supports are a command line and web. So I'll jump into the demo of the tool. Firstly, I'll talk about the Java MOP properties. So Java MOP has various predefined properties such as hasNext, SafeNum, SafeLock, and users can also define their own properties with the help of Java MOP syntax, which is available on their project website. The approaches to parametric monitoring, there are two approaches, static weaving and Java MOP agent. I will be demonstrating static weaving with the hasNext property. Java MOP agent is basically a jar file which is generated with the help of a few commands, and this jar file is portable and can be used on any system to monitor the target program. Now let's talk about the hasNext property. This property ensures that one does not use the next element in an iterator without checking for the existence of the next element. So the property states that every time a next element is seen, there should be a hasNext event immediately preceding it. So first let me show you the MOP file which has the specifications pertaining to this property. This is the hasNext MOP file, and it comes predefined with the tool. There are three events: hasNext true, hasNext false, and next event. If this property is violated, then the following error message is printed on the command line: next call before hasNext. Now let me compile this property using the following command. So now a bunch of things will happen. Firstly, a .rvm file is generated with the help of RV monitor. Then a .aj file is generated with the help of AspectJ compiler. Let me first show you the target program that we'll be using. So this is our test program. This is a vector in which the elements are getting added. This is the iterator. So now here, next method is getting called before the hasNext method. Hence, there's a clear violation of the hasNext property. Now let me show you the .aj file that was generated. This is the .aspectj file which was generated by the Java MOP tool. Here are a few point cuts which are of point of interest as far as the violation or abiding by the property goes. So this is the next event, hasNext true event, hasNext false event. And this is the .rvm file that was generated by the tool, and this is basically the monitoring code that will monitor our target program. So now let us weave our .aj file with our target program. By weaving, what we mean is that whenever the next method is called in our target program, we'll have a next event right before the next method call. So this is what we mean by weaving, static weaving of the AspectJ code with our target program. So now the weaving is done. Now I'll simply run my Java code. And we see this error, next call before has next. Now, since the event call was before the method call in our weaved program, therefore the system was alerted that there is a violation of the property and this error message got printed. Now, when I tweak the code and remove the violating portions of the code, I should not see this error. So let's repeat this process again with this tweaked code. I'll compile the property again, .mop file. Then I'll weave the code again. Then I'll run the Java program again. And the error goes away. Now going back into the presentation, the advantages of using this tool are there are a lot of parametric monitoring tools on the market, but this one claims to be the most efficient in terms of runtime overhead, and it is very competitive with respect to memory usage. The limitations of the tool are there is a heavy dependency of JavaMOP on the AspectJ compiler. So JavaMOP only allows events which can be defined in the standard AspectJ. Another limitation is that weaving time optimization cannot be performed because JavaMOP relies on external AspectJ compiler for weaving monitoring code. For more information, please refer to the following project website. Thank you.